Everyone, my name is Daniel Febrian, and I'm with my friend Muhammad Gandhi, Tengku Firman, and Amel Moni. We are going to present our research analysis of photocopy industry waste management at Universitas Pertamina using the life cycle assessment method. So, photocopy services are essential for supporting academic activities at the university. However, these services also generate environmental impact. So, first, large amounts of paper are consumed every day, contributing to resource depletion and solid waste generation. And second, the tolerant gases are classified as a hazardous waste because they contain a carbon dioxide and synthetic flavors, which may contaminate soil and water if improperly managed. And then the third, photocopy machines consume significant amounts of electricity, and since the mainly relies on fossil fuel-based electricity, this results in the greenhouse gas emissions. Therefore, life cycle assessment or LCIA is used to systematically identify environmental hotspots and propose a sustainable improvement strategy. So, in the previous studies, mainly focus on paper manufacturing or large-scale printing industries. Previous studies evaluate the small-scale photocopies services on university campuses, especially in Indonesia. In addition, previous research readily combines paper, electricity, and waste into one integrated environmental assessment. So, this study follows the ISO 14040 and ISO 14044 standard, which consists of 4 phases. The first phase is goal and scope definition, where system boundary and functional unit are determined. The second phase is lifecycle inventory, where all the material and energy inputs and outputs are quantified. The third phase is lifecycle impact assessment, where inventory data are converted into environmental impact indicators using the recipe 2016 midpoint method in OpenLCA. Finally, the interpretation phase identifies environmental hotspots and develops recommendations for improvement. So the research began with an initial screening to identify important environmental aspects. Data were collected through direct observation, interviews with photocopy staff, professional records, and supporting documentation. And then finally, the environmental aspects were prioritized based on their significance, paper, electricity, and honor were identified as the highest priority contributors.
The aspect and impacts identified. This table summarizes the environmental aspect identified during the study. Paper consumption contributes to research situation and solid waste generation. Toner utilizing waste hazardous waste and investment activity is not properly management. Overall, paper waste generation and toner cartridge disposal is identified as highly significant environmental aspect requiring proper management. Let's have a goal and scope definition. The system boundaries used in research is get to get, meaning on activities inside the photocopy facility are analyzed. The functional unit is one sheet of A4 or B4 photocopy paper. The operational standards were compared exciting condition, research, efficiency improvement, and risk management practice. Slide 8, life cycle inventory. This slide presents the life cycle inventory result. The inventory includes the quantities of electricity, paper, toner, and other material flows and leaving the system. Among all inputs, paper consumption is the large followed by electricity and toner. Before conducting the impact assessment, inventory data were verified using the mass balance principle to ensure data consistency. Slide 9, life cycle impact assessment. The impact assessment was performed using the recipe 2016 midpoint method. The results show that climate change is the dominant environmental impact category, mainly caused by electricity consumption. Slide 10. Comparing three scenarios. The operational scenario will compare scenario 1 present the current operational condition and produce the highest greenhouse gas emissions. Scenario 2 focuses on the research efficiency impact. Activities scenario implemented impact across almost all categories. Scenario 3 is the waste management that requires additional energy, resulting in slightly higher fossil research consumption than scenario 2. However, scenario 2 provides environmental performance.
Next, toxicity reduction and trade-offs. This figure compares environmental impacts across different categories. Scenario 2 reduce human carcinogenic toxicity by approximately 92% compared to scenario 1. In addition, particulate matter formation and acidification are almost completely eliminated. However, scenario 3 shows a trade-off because additional waste treatment activities increase fossil resource consumption. Next, scenario comparison. This chart clearly shows that scenario 2 consistently performs better than the other scenarios. Scenario 1 has the highest impacts in toxicity and ecotoxicity categories due to intensive toner use and higher resource consumption. Therefore, efficient resource utilization combined with better toner management significantly reduce environmental impacts. Next, interpretation. Based on the interpretation stage, electricity consumption is the main environmental hotspot because it contributes the most to climate change. Toner is the largest contributor to toxicity impacts among the three scenarios. Scenario 2 is the most environmentally sustainable because it achieves the lowest impacts across almost all categories. Although scenario 3 improves waste management, additional processing energy creates a trade-off in fossil resource use. Next, conclusion and recommendation. In conclusion, paper, electricity, and toner are the major environmental hotspot in photocopy operations. The current operational condition generates the highest greenhouse gas emission. Resource efficiency, represented by scenario 2, reduce greenhouse gas emissions by approximately 63%, while also lowering toxicity impacts. Based on these findings, we recommend using energy-efficient photocopy machines, promoting double-side printing, reduce unnecessary paper use, increasing digital documentation, and implementing proper hazardous toner waste management. Future research could expand the system boundary from gate to gate to cradle to grave and evaluate renewable energy. Thank you very much for your attention. We appreciate your time, and I will be happy to answer any question. Thank you.